Okay, I think we're recording. I'm going to keep my fingers crossed. Okay, so today we're going to look at 1.4. And of course, in chapter 1, we just go through 1.4. So that's why we're looking at a test. Okay, so the first thing I want to do is do a review over exponential functions. All right, so that's what we're going to look at first. Now, where you will see exponential functions is when they're talking about growth or decay. So you could have an like when we first started talking about the pandemic, we did not want it to have an exponential growth because that just means those that test positive, it just goes up and up and up and keeps going forever, okay? So this could be obviously in the medical, in sciences. If you are doing a petri dish and looking at growth, it can be population of communities, all sorts of things. NOC, you could look at exponential growth or decay in enrollment, all right? So it's used a lot. All right. So when you have f of x equals the base number b raised to the x power, exponential function, so our variable or unknown is in the exponent. All right, so we're going to look at two different ones, and that is when b, your base number, is greater than 1. And over here, we're going to look at when b, or your base, is less than 1. All right. So if you recall from exponential functions, when you're dealing with an exponential function, it always passes through, whether it is growth or decay, it always passes through the point 0, 1. When b is greater than 1, this represents growth. So that would kind of look like this. This gets closer and closer to the x-axis but never touches it, and then this has exponentially, it just continually goes up forever, all right? Now, when b is less than 1, this is when we're talking about decay. And that would be when it looks like this. So these are just some reminders of some functions. I know that they were discussed in STEM, in functions. I don't know that you guys discussed this, but these are some set rules that you need to know, okay? All right, then we also have log functions. And this is taking the log of something, and if you will recall from, if you'll look on your calculator, you have, like, here's the log button here. And we did log in class before. Now, again, this deals with growth and decay, but it's not going to look exactly like your exponential. What this function looks like is f of x equals log base b x. F of x equals log base b x. So again, what we're looking at is the b. If your b is greater than 1, and when your b is less than 1. Now, for these, they do not pass through 0, 1, but they pass through the point 1, 0. Now, one of my brilliant colleagues gave me this little trick, and I was like, that is brilliant. So when you're talking about the two functions, if you can't remember if it's passes through 0, 1 or 1, 0. All right, here's the way to remember it. How do you spell log? L-O-G. L-O-G. So that's the way to remember which point goes with log. And of course, if you remember that, then you know the other one is the one that goes with exponential. So I love that little trick. All right, so when b is greater than 1, again, that deals with growth. It passes through 1, 0. Let's see if I can make this. And it looks like, whoops, seriously, my pen is not good right. There we go. And so here, less than 1, decay, would look like this. Okay? Now, on our calculator, we have the log button. So notice on your calculator, and when we just write log, nothing is put there. Does anybody recall what base is understood? 10. Log base 10. So your calculator, because that's what we deal with a lot, is log base 10. Now, there is a log base e. E is kind of like pi. We know pi to be 3.14. E is a value that's 2.71, I believe 8. But this, when you see log base e, that's not on your calculator, but it is the same thing as what we call natural log. So this is what you would look for on your calculator. So that's just kind of a refresher on those functions that we may see as we go throughout the semester, okay?
ln, right?
I'm sorry?
I was just making sure the log he is ln, right?
That is ln,
Just
which stands for natural log.
Thank you.
All right. All right, so now what we're going to do is we are going to look at what are called piecewise functions. Now, the key to this is basically we're going to be given some functions and it's going to break our graph up into pieces. That's why it's called a piecewise, okay? All right, so I'm going to give you an example of what this is going to look like. So your function, and then it's going to give you several different ones. It's going to say x plus 5, 3, 5 minus x, and then it's going to give you some restrictions. X is less than -2. X is greater than or equal to -2 but less than 4. And x is greater than or equal to 4. Now, think back to functions, and we have the input, which we talked at the beginning of class is also known as which value? That's your x. That's also known as the, what was that word? Domain. So what they're telling you is, here is what you look at of your x values. So your domain, depending upon what number is your input, it tells you what function or what rule to follow. And of course we know this rule then would give us our output. So this deals with our input. So once we determine what our input is, we say, okay, that falls within which one of these, and then it tells us which rule to use. Now, you can also look at this as equations, right? So when we look at the x plus 5, you could look at that as, okay, that is the equation y equals x plus 5. This is y equals 3, y equals 5 minus x. Because we know f of x you can interchange with y, okay? All right, so what we're going to do is first look at how to read this, and then we're actually going to graph it, because that's one of the things that you may be asked to do. So, how to read. All right, so if we have the function at -1, okay, so this is your x, this is your input. So I'm like, okay, here's my input, which is my domain. -1 is less than -2, so it tells me to use this rule, x plus 5, which means I'm going to put in -1 plus 5, which is 4. So that would give you the ordered pair -1, 4. F of 6, so I come up here and I go, okay, my domain 6 is bigger than 4, so I'm going to use 5 minus x, so I would do 5 minus 6 is equal to -1, so that's going to give me the point 6, -1. And if we do f of 0, and I go, okay, 0 falls between -2 and 4, so it just tells me my output is 3. So this tells me when I input 0, all I have to do is give the output of 3. I don't have to do any calculations. Okay? So that's how to know which rule to follow. All right, so now we're going to look at a graph. All right, now this graph is going to have 3 different pieces because we have 3 different functions, okay? So here is the easiest way to do it. So I'm going to look at my first rule, and this is when my x values are less than -2, all right? Now, the first thing I'm going to do is, what happens with this rule when x is equal to -2? That's what I'm going to ask myself first. Okay, so the first thing is, can it be -2? No, because it doesn't have the or equal to, right? All right, but I'm going to go ahead and I'm going to look at this at -2. But I know it can't, is that supposed to be, yes, okay. I know it can't be -2, okay? Let me put this over here. So this is rule number 1, just so you can see it. So we have x plus 5, okay? And I want to see what happens when that is -2. So we get 3. So we know that produces input of -2, output of 3, but because this does not have the line under it, it cannot be at that point, but that is my good starting point. So I'm going to go -2, up 1, 2, 3. I'm going to find that point, and I'm going to do an open circle. Now, you can plug and chug some more numbers. If you wanted to put in a number smaller than -2, like say -4, what would your output be? One. -4 plus 5 is 1. So you could go -4, 1, and you know that point is on there. And once you have 2 points, so this is the graph of that first function. All right? Now we're going to do the next function. So the next function, come over here. Sorry to not put it together, but I'm running out of room over here. So the next one had the domain. So this is your output, right? But its domain was anything from -2 to 4. So let's just look at the domain at -2. Can it be -2? Yes. So when you input -2, what's going to be the output? 3. So I'm going to go -2, 3, but now this one is included because this function says it's equal to that. All right, what happens if whoops, sorry, you can't see it. What happens if I choose another number in between these two? Say I said -1. So if the input is -1, what is your output?
3.
Don't make it too difficult.
3.
3. So I would go -1, 3. There's another point on it. So I'm going to go all the way over to my other end point, which is 4. Can it be 4?
Yes.
Be careful.
Oh.
Cannot be 4. So I'm going to do an open circle, but if the input is 4, what is the output?
3.
3. So I'm going to go to 1, 2, 3, 4, and 3, but now it's going to be an open circle, so here's my second piece. What type of line is that? Horizontal. What is the slope of a horizontal line? 0. Now we're going to look at when x is greater than or equal to 4. So now it can be equal to 4. So let's see what happens when I have an input of 4. If I input 4 using this rule, what is my output? 1. So I'm going to go wow, I did a funky thing. Okay, so I'm going to go over 4, up 1. Can it be this value? Yes. So I need another point. Is 5 bigger than 4? So let's do an input of 5. If I input 5, what is my output? 0. So I'm going to go over 5, 0. So here is my piecewise. This was the function x plus 5. This was 3, and this was 5 minus x. So that's how you read and graph a piecewise.
Can there be any open circles on the line? Like, see it's open on the top one, but it's closed on the bottom one?
Well, that's because they don't hit at the same point.
Yeah, but can there be 2 open circles on the same
Yes.
line? Okay.
If this did not include the 4, this would be an open circle as well. Which then, if that was gone, basically then there is, x could never be 4 because it's saying it's never 4. Does that make sense?
Yeah.
Okay, okay. All right. Let's take a look. This can be looked at as a piecewise function as well. But we're going to look at the absolute value function. Now, what I'm talking about is absolute value, right? So what is the absolute value of 15?
-15.
Be careful.
15 and -15?
Just 15.
Or did I have that wrong?
Output will never be negative, okay? The input can be, all right? All right, so, here's what I say. So we know the absolute value of 3 is 3. The absolute value of -4 is 4. Because remember, absolute value is distance. how far are you from 0? It doesn't care which direction, okay? All right, so we're going to look at the function of the absolute value of x. Now, it can be written as a piecewise. So think of the domain when x is greater than or equal to 0. What kind of numbers, when you have this domain, what kind of numbers are you putting in the x? Well, what kind of numbers are bigger than 0? Positive numbers. So this is saying positive numbers. So when I put a positive number in, so I'm putting just an x in, and then I would look at it within the function. Now we're also going to look at when x is less than 0, and what type of numbers are those? So here's what happens. Here's why this is negative. Because if I choose a number smaller than 0, like -2, this would say take the opposite of -2, which is 2. So your output would actually be +2. Does that make sense? Okay, so let's take a look at what this graph looks like. Now, let's take this first piece. What happens at 0? So if x is equal to 0, your output will be 0. If your input is 1, what is your output? 1. If your input is 3, what is your output? 3. All right, I think we can get an idea of what this looks like. Now we want numbers smaller than 0. Okay, so -1 is smaller than 0. So this reads take the opposite of -1, which is 1. So when I put in -1, I get the output 1. -3 as your input is a number smaller than 0. And the opposite of -3 is, so you get -3, 3. So it looks like this.
V.
So notice, depending upon which piece you use, input can be any number. What about the range? Notice how the range, the output is never negative, right? It's always here. So if you're looking at your y-axis, your range is anything from 0 to, and each one of these, all the way to infinity. Okay? All right, now, one of the things, and we're going to use this graph to also do this, and this is when you look at the shifts of graphs. Meaning we're going to take a graph and we're going to shift it. All right. So one of those is when you take the function and you add a value. This tells us to shift up a units. So like it might say +3. So we would shift the graph up 3 units. You could have the function -a. What do you think the shift's going to do there? We're going to shift down a units. Now, this is a shift up or down. So this is a shift up or down, which means we have a vertical shift. It's going to go up or down. Typically, students do okay with this one, because it makes sense. Plus is up, negative is down. The one where there's a little bit of you have to pause, is when the a is on the inside of the parentheses with the function. So notice this is a constant outside of it, this is on the inside of it. Now we are going to have a shift, but it shifts left a units. Now that's where it's a little bit confusing, because when we think up here, we think to the left going in the negative direction. And left is actually plus a, so you do it the opposite of what you think it would be. So x minus a means you would actually shift, what do you think? To the right a units. So it kind of goes opposite of what you think it would. So this shift is horizontal shift, either left or right. Now, the function we had above was f of x equals the absolute value of x. So that is this graph here, okay? I'm not going to rewrite that graph. We're going to look at that graph with some shifts. All right, so here's one example. Suppose it told you to take y equals the function minus 2. Well, we know this function, so the function is the absolute value of x minus 2. So what you want to do is pay attention that this constant minus 2 is outside of what the function was. So the minus 2 would tell me to shift it what? Down. So when you look at this on a graph, so here's where the original was at, so we're going to shift it down 1, 2, and so then it would look like this. Whereas the original was right here. So it shifted 1, 2 down. If it looked like this, y equals f of x minus 3. So that tells me to put this within the function. So that would be the absolute value of x minus 3. So notice the constant is within the function. Minus 3, be careful, tells you to go which direction? The right. It's the opposite of what you think. So you need to go to the right 3. So if we were looking at this, and we know here is the original, we're going to go to the right 1, 2, 3, and it would look like this. So it just shifts it. Right? All right. Then the last topic for this particular unit is what we call composite functions. All right, so I'm going to give you two functions. I'm going to give you the function f of x is equal to 2x squared minus 5x plus 6. And just for kicks, what's the domain of this? Negative infinity to infinity, all real numbers, because it's a polynomial. Okay, it's not a radical, it's not a rational, so there's no restrictions. All right, then the other g of x function is 6 minus x. What's the domain?
Anything but 6? Or am I thinking the wrong?
That would be true if this was in a denominator. If you had 1 over that, I would say yes. Again, it's not irrational, it's not a radical, so you don't have to worry about anything. It's all real numbers. The only time you have to worry about it is if there's something in the denominator or if it's under a radical. Otherwise, bam, all real numbers, okay? All right, now, one of the things that you may be asked to do is just to find, say, f of negative 2. So that means, because of the function f, I'm going to go to that function, and in place of x, I'm going to put negative 2. So 2 times negative 2 squared minus 5 times negative 2 plus 6. Now, you can put all of that into your calculator, or let's see, negative 2 squared is 4, 2 times 4 is 8. That would be plus 10, plus 6, 24. So that's one thing that you may be asked to do on WebAssign. It may ask you to do that, but not necessarily numerically. It might say g of z. So what that tells me is use the g function, and everywhere there's an x, I'm going to put a z. So all I would do is 6 minus z. I'm going to do one more. What if it g of, let's see, I'm going to say x plus h. So that means use this function, 6 minus, and in place of the x, what are you going to put? X plus h. Now, because of this minus, you have to be careful. It's going to be x plus h, so you actually have 6 minus x minus h. And that's what it would look like. Okay? All right. Now the part that causes a little bit more stumble. And this is when you do composition, and it's going to read f, open circle, g of x. That is not multiplication. The open circle means it's composition. So this is what it actually means. Notice the f is first. So then what I'm going to do is take the f function, and I'm going to replace every x with g of x. Which means I'm going to take the f function, and everywhere there's an x, I'm going to put what? 6 minus x. So here's what it would look like. 2 times 6 minus x squared minus 5 times 6 minus x plus 6. Now, this 6 minus x squared, I'm going to come over here and to the side and do that. That is not 36 minus x squared. Every time you do that, a kitten dies. 6 minus x squared means 6 minus x times 6 minus x. You're going to have to FOIL. Whoops. I meant to write 6 minus x here. Sorry. This is 6 minus x. This is why you should do pencil. Okay. First times first is 36. Outside is minus 6x. Inside is minus 6x. Last is plus x squared. So in essence, it gives you 36 minus 12x plus x squared. Now, for my people that have done this a lot, I'm going to show you and remind you of something that is really quick. If that doesn't work for you, take the time to do this on the side. But anytime you have a binomial squared, square this, multiply those two. 6 times negative x is negative 6x, and double it, negative 12x, and then square the last one, plus x squared. Then I'm going to distribute this, so I get minus 30 plus 5x plus 6. Now we're going to distribute the 2. 2 times 36 is 72 minus 24x plus 2x squared minus 30 plus 5x plus 6. So then what I'm going to do is I'm going to combine like terms and put it in descending order. So here is my x squared term. It's the only one, so I'm going to put it first. I dealt with that one. Then I'm going to look for all my x terms. So I have negative 24x plus 5x. Signs are different. Subtract and use the sign of the larger. Minus 19x. And then we have our constant, 72 minus 30 plus 6. So 42 plus 6 plus 48. All right, then of course, you're going to see somewhere it reads g f of x. So again, g is the first one, so I'm going to take the g function, and everywhere there's an x, I'm going to replace with the f function. So the g function with the x, I'm going to replace the f function, which is 2x squared minus 5x plus 6. So I'm going to go up to my g function, which is 6 minus, and this is what I was telling you earlier, be careful, you have to include those parentheses, because subtraction, your sign will change with everything. So this is 2x squared minus 5x plus 6. We're going to distribute that negative through, so it becomes plus 5x minus 6. So here's my squared term that I'm going to put first, negative 2x squared, 5x, and then 6 minus 6 is what? So this would be my answer.
Do the other signs still want it negative, or do they want us to like make it the first number positive?
If I did, I can't do that because I don't have an equation. So if I had 0 equals negative 2x squared plus 5x, I could multiply both sides by a negative and get rid of it, but I don't have an equation. It's not set equal to 0. This is just the function, and yes. What this is, it's a parabola, and because this is negative, we know it goes downward. Okay? So you will leave it negative. Okay? All right. I want to show you one more that could occur that you will see in WebAssign. And they might throw at you this. So it's saying we're just going to be working with the one function. If you remember, g of x was 6 minus x. Okay? So what that means is take the g function and in place of x, put g of x. So take the g function, g of x was 6 minus x. So in place of x, so I'm going to have 6 minus, and in place of x, I'm going to put 6 minus x. So that gives me 6 minus 6 plus x. Well, what happens? Yeah, your 6 minus 6 is 0. So you're just left with x. So that's the basis of those. You're going to see several of those on your assignment. So does anybody have any questions on that?